In this video, we are going to learn how to classify polynomials and how to describe end behavior. We'll start with the standard form of a polynomial function that arranges its terms by degree. And what the degree is the power that the terms are raised to. So we'll go from the highest power term to the lowest power term when writing a polynomial function in standard form. Here's an example just below it. For p of x is equal to 4x cubed plus 3x squared plus 5x minus 2. You'll see the powers go down in descending order as I go from left to right, with the red term being my cubic term, the blue term being my quadratic term because it's squared, the 5x being my linear term, and then the 2 being my constant term. Now, how do we name these polynomials, i.e. classify the polynomials? So let's go first by degree. So let's start with this first example of 5. Since there is no x term next to it, that is a constant term, so we call that a degree 0 and a constant. Next up, we have x plus 4, which is a degree 1 term, and we call that a linear polynomial. Next up, we have 4x squared, that is degree 2, which we refer to as a quadratic, just like in the last unit. And here we have 4x cubed. Again, we always just go off of whatever the biggest power term is. So even though there is a quadratic and linear term, this is based off the highest power. So that's a degree 3 polynomial, which we refer to as a cubic polynomial, being the highest power. Here we have 2x to the fourth plus 5x squared, 4 being the highest power, so its degree is 4, which means, and we'll call this a quartic polynomial. So definitely different than quadratic, quartic. And lastly, whenever it's degree 5, we refer to that as a quintic polynomial. Usually after quintic, we just say degree 6, degree 7, but there are a few names out there you could use as well. Now, based on the number of terms, so it's definitely a constant polynomial, but if there's only one term in the polynomial, we call that a monomial. If there are two terms, we refer to that as a binomial. And even though this one is a quadratic, a degree 2 polynomial, we still only has one term, so it's a monomial. So you would say constant monomial, linear binomial, quadratic monomial for the classification of that polynomial. Now, when you have three terms, that's referred to as a trinomial. For tri for 3, bi for 2, mono for 1. And then for two terms, that is a binomial again. But if you ever have more than 3 terms, in this case 4, we just say a polynomial of 4 terms. Just because we don't have anything past tri, but we'll just count out how many terms there are. Now let's write each of these polynomials in standard form. Then what is the classification by degree and then by number of terms? So first we have 3x squared plus 3x plus 9x squared plus 5. So to put that into standard form, we put the highest power term first, which would be 9x squared. And then we follow that with the next power term, which is 3x. And we end it with the constant that is usually a degree 0 term. So it goes down in powers. Now just looking at this, I can see that it's a degree 2 polynomial. So that would be a quadratic for degree 2. And since there are 3 terms, we refer to that as a trinomial. So a quadratic trinomial. Now this one has a lot of terms, so we have to order them to put it in standard form. So we have x to the fourth as our first term. Now next up, the next highest power term are these x squared terms. So these are like terms, so we're going to combine them. So negative 6x squared plus 10x squared gives me positive 4x squared. And then we have 4x would come next. And then minus 12. And that gives us those 4 terms. So that is our standard form of the polynomial. And again, you have to combine those like terms. But you can see here that it is degree 4 being the highest power. So it's a quartic. And now we have 1, 2, 3, 4 terms. So it'll be a quartic polynomial of 4 terms. It used to have 5 terms, but since we found those like terms in the middle, that brought it down to 4, making a quartic polynomial of 4 terms. Now let's talk about what end behavior is. Now end behavior is on the graph, looking at where the arrows are ending up pointing. Usually they're going to be pointing upwards or downwards in some of the quadrants. So here we have 4x to the 4th plus 6x cubed minus x. Here's what the graph roughly looks like. And its end behavior we will say is up and up, meaning it goes up to the left. You always start with the left one, and up to the right. Another way to write this end behavior is to write it as x goes towards negative infinity, another way to say left. If you look at the x-axis, as I go to the left, y goes towards positive infinity. And as x goes towards positive infinity, y would also go to positive infinity. So it's 2 ways to write end behavior. And you'll see here the one on the bottom is a little more specific because it's saying as x goes to the left, y goes up. As x goes to the right, y also goes up, really describing the behavior of the graph. Another end behavior we might get is y is equal to negative x squared plus 2x, which we see here as down to the left and down to the right. So we call that down and down. And if I wanted to write that with my little arrows down here, as x goes to negative infinity, meaning the left, the y is going towards negative infinity as well. And as x goes towards positive infinity, which is the right, y also goes towards positive or negative infinity. So you'll see here, wherever you're using this bottom method of writing end behavior, you'll always have an as x goes to negative infinity and an as x goes to positive infinity, since you always have a left and a right. But that will determine what y approaches in those directions, because now you'll see here y can go either up or down. Next up, we have y is equal to x cubed. So here we see it goes down to the left, but then up to the right. So we call that down and up. So you would write that as x goes towards negative infinity. We're seeing here y also goes towards negative infinity. And as x goes towards positive infinity, the right, y goes towards positive infinity. So you'll see here that they don't both go in the same direction now. They can go in different directions. Sometimes one side can go down, the other side can go up. We'll see that happen on the right here as well with negative x cubed plus 2x. We'll see here that it goes up to the left and down to the right. So as x goes towards negative infinity, y goes towards positive infinity, as you see here. So as I go left, the y values go up. And as x goes towards positive infinity, the right, the y values go down towards negative infinity. So there is a pattern to this. Based on the leading term, the highest powered term, we can actually determine end behavior just looking at that one term. So you'll see here, whenever the degree was positive, they would always go in the same direction. And when it's negative, when it's even the power, they both go in the same direction. And when it's odd, they go in opposite directions, as you see here. One would go up and one would go down. So just based off the power alone, we can determine some end behaviors. And now, depending on whether or not the first term was positive or not, that actually indicates what the right end behavior is. So whenever a is positive, that number in front of the x to the powered term is positive, we always go up to the right. And when it's negative, we always go down to the right. So using the combination of these bits of information, again, if the power is even and a is positive, it's going to go up and up. Because when a is positive, it goes up to the right, and when the power is even, they'll go in the same direction. So again, if a was negative, I know it's going to go down to the right. And since the power is even, it should also go down to the left because it should go in the same direction. So if I did that with the odd, when n is odd but a is positive, as you see in this bottom left example, it's definitely going up to the right, but since it's an odd power, we say it goes down to the left in the opposite direction. And for the last one, when a is negative, it's going to go down to the right, but it's going to go up to the left, so up and down. And these patterns exist all over. So for example, this quadratic trinomial, its leading term is 9x squared, so it's positive. So a is positive, and the power is even. So the end behavior would be up and up. That's kind of what you expect when a is positive for a quadratic. It's a parabola opens upwards, so you can see here it goes up to the left and up to the right. And that's how you classify polynomials and describe end behavior.